Good day, grade 11 pre-matric students. Welcome to the lesson. This is Sir Nicholas, physical science teacher, and I'm going to help you on your term 3 so that you can pass with distinction and proceed to grade 12 with pleasure. I will need you to have a pen and a paper so that we can do some notes, and then the thing which I always tell my students is that for you to master this topic or all these topics that you're going to write on your final examination, you need to practice. You need to practice and you need to make sure you do different examples so that you can grasp fully what is required from you. So let's start with quantitative aspects of chemical change. Quantitative aspects of chemical change. What is it that is a quantitative aspect of chemical change? Okay, let's start. One mole. One mole. Definition of one mole is defined as, let's say, one mole is defined as the one mole is defined as the amount of substance having the same number of particles as there are atoms in 12 gram carbon 12. Relative atomic mass as the number of particles on a scale where an atom of carbon 12 has a mass of 12. Avogadro's number. Avogadro's number, you should always remember that we write Avogadro's number as Na. Okay, because when it comes to formulas which you're going to use, you will have n equals to n divided by Na. So here Avogadro's number is Na, which is the number of particles, atoms, molecules, formula units present in 1 mole. So Avogadro's number is equals to what? 6,023 times 10 to the power 23 per mole. You need to make sure that you go to your question papers and visit the back of your question paper. You will find this number. You need to make sure you do that, because this Avogadro's number is at the back of your question paper. And the last thing, you need to define molar mass. What is molar mass? You define molar mass as the mass of 1 mole of a substance measured in gram per mole. Okay, molar mass is the mass of 1 mole of a substance measured in gram per mole. Okay, so far nothing really special about the intro. Let's just go to the next slide. So as you can see, 1 mole of each substance. So we got the following. The following contain 1 mole, which is 6 times 10 to the power 23 atoms. So 32 grams sulfur, as you can see. Let me try to zoom. You can see sulfur. It looks like, what does it look like? Honestly, it's gray in color. But 32 grams sulfur, 12 gram carbon. Carbon is black, eh? Oh, carbon. I know why carbon is black, because carbon is released when you burn coal. Am I lying? Carbon is released when you burn coal. Carbon. Malasha. Zinc. Look at zinc. Wow. So beautiful, man. Look at zinc, man. Damn. But 65 gram of zinc, which means that 65 gram of zinc is greater than 12 gram of carbon, which is greater than 32 gram of sulfur. So, wow, look at the copper sulfate. Copper sulfate times 5 H2O. Wow. It's blue in color. It's nice. I love blue. Blue is my favorite color. So we have 250 gram of copper sulfate, 18 gram of H2O, as you can see. And we have table salt, Majoro. Table salt is the one that you use like ZCC, they use this table salt. Don't laugh, but yeah, it's NaCl, sodium chloride is table salt. Okay, so these contain 1 mole of molecules or formula unit. So 32 gram of sulfur contain 1 mole of molecules, which means that 32 gram of sulfur contains 6 times 10 to the power 23 atoms or molecules of Avogadro. You understand? The relative atomic mass of an element is the mass of a particle on a scale where an atom of carbon 12 has a mass of 12, only represented by a number. Um, Number of sodium is 23. The relative formula mass of a compound is the sum of the relative atomic masses of all the atoms in the compound. You can see relative formula mass of water is H2O. When you go to your predictable, you will find that you got 2 times 1. 1 is from the hydrogen on your predictable plus 16, which is the atomic mass of oxygen, 16. Then 1 time 2 plus 16 will give you 18, relative atomic mass of relative formula mass of water. And the molar mass formula mass is the mass of 1 mole of a substance measured in gram per mole. You know, molar mass, you gotta use that formula. N equals to small letter m divided by big capital letter M. This is episode 1. I will make the next episode where I'm trying to show you different examples when we use the formulas which we apply on stoichiochemistry on this topic, chemical change. You know, so yeah, this is what I was talking about. The relationship between mole mass and molar mass. Look at this formula. This is the most frequently used formula, it all started from grade 10. If you can remember, grade 11 students, you can see N represent what? Mole. And small letter m represent what? Mass in grams, which means if they give you in kg, you need to make sure you convert it to grams. And we also got a big capital letter M, which represents molar mass, okay, which is measured in gram per mole, because we're looking for number of moles, which is gram divided by uh, gram per mole. Then you will find moles, because gram and gram will cancel each other. 1 over mole will give you mole. If you don't understand, I will make episode 2 where I'm trying to explain how this formula came to be, and what types of different formulas we can use in different examples. Look at this one. This is just an intro, so it's good to show you before we can do different questions. N here represent number of mole, and the on top we have big capital letter N, which represent number of particles, and at the bottom we have this Na, which is Avogadro. Okay, remember, Na is not the same as big capital letter N. Na, it represent Avogadro, which is 6,02 times 10 to the power 23, as you can see, Avogadro's constant. And this is the relationship between mole mass and molar mass. Please, before we do question papers, please know these formulas. Make sure you know these formulas, okay? Make sure you know and understand these formulas, because we're gonna use them most of the time, okay? So let's go to empirical formula. How to calculate empirical formula? There are steps when it comes to calculating empirical formula. First of all, you need to convert your your percentage to masses, because you'll be given different elements to make a compound in percentages. Let's say they give you 70% carbon, 30%, no, 20% oxygen, and 10% hydrogen. So you need to make sure you take those 70% carbon and convert it into mass. The 70% becomes a, a, a mass in grams. Okay, let's check these empirical formula steps so that it will aid us on calculating when you do questions on episode 2. Remember, this is an introduction. I will show you how to calculate on the next episode. Okay, step 1. Okay, on calculating empirical formula, you can see that you need to assume 100-gram sample, get x gram of each element, which means that convert the percentage to grams. Step 2, divide by the atomic mass to get the number of mole of each element. Okay, so here you're going to use the formula, which is n equals to m small m divided by bigger M, which is n equals to mass divided by molar mass. And then step 3, you're going to write the ratio from the balanced equation. Okay, step 4, you're going to divide all the number by the smallest whole number ratio. Remember, empirical formula definition, it says is the simplest whole number ratio of atoms in a compound, and round off to whole numbers, at least round it to two decimal places. I always tell my students, don't quickly round the number when you're calculating number of moles. Try to do it at the last step when you are converting, dividing all step 4, dividing all those numbers in by the smallest whole number ratio. And step 6, you need to write the empirical formula in the simplest uh, ratio form. Okay, I'm gonna show you, don't worry. Let's go to the next slide. Okay, look at this example. Okay, determine the empirical formula of a compound containing 56.5% potassium, 8.7% carbon, and 34.8% oxygen. I always tell my student, if you add this potassium, carbon, and oxygen percentages using a calculator, you will get 100%. Okay, 56.5% plus 8.7% plus 34.8%, it will give you 100. Okay, which makes sense. That's why this side they say that on step 1, assume 100-gram sample, get x gram of each element. Okay, that's what they're trying to say. So you will make a table if you prefer to do it this way, or you will write it however you want. So I'll advise you to use a table. You can see element KCO and then gram per 100 gram, because the percentages, when we add them, it will give us 100 gram, which is 100%. Convert percent to gram, don't get confused. Remember, on potassium we got 56.5, on carbon we got 8.7, and on oxygen we got 34.8. Now we're gonna apply the formula, most frequently used formula, n equals to small letter m divided by bigger capital letter M, which is calculating number of moles. And then you're gonna calculate number of moles, and then you divide the mass by the molar mass, and then you get number of moles. And then from 1.45 and 0.73 and 2.18, you will find the simplest whole number ratio, which number is smaller compared to, between 1.45, 0.73 and 2.18. Of course the answer is 0.73. Then you're gonna divide 1.45 by 0.73, you will get 2 for potassium, and divide 0.73 by 0.73, you get 1 for carbon, and divide 2.18 by 0.73, you get 3 for oxygen. And then the way you write your empirical formula, you must write it in this way: K2CO3, which is potassium carbonate. Okay, potassium carbonate. Remember, students, I want you to pass chemistry with distinction. Just respect your teacher. And then simple empirical formula, it's easy, 3 marks, 6 marks. Most question papers, they will ask you for 5 marks, 6 marks, also by defining the empirical formula. And then let's go to hydrates. The crystals of some salts have a specific number of water molecules attached to them. This is the water of crystallization. Yeah, let's talk about what's water of crystallization. What is happening when it comes to water of crystallization? So these salts are called hydrated salts. When heated, the water molecules is released, and the salts are called anhydrous salts. Okay, these salts are called hydrated salts. When heated, the water molecules is released, and the salts are called anhydrous salts. Okay, Let's go to copper sulfate times 5H2O. You can see they said blue and copper sulfate. This side is white plus H2O. Oh, I mean this compound copper sulfate times 5H2O is broken down into what? Into, remember this is an hydrated salt. Okay, it's broken down into anhydrous salts, because they say the crystal of some salts have a specific number of water molecules attached to them. This is the water of crystallization. Okay, so these salts are called hydrated salts. This blue salt, copper sulfate times 5H2O, is then when heated, the water molecules is released and the salts are called anhydrous salts. You can see it's white now. It was blue and then it was heated, and then we found two reactants, which is copper sulfate plus H2O in liquid, copper sulfate in aqueous solution, and then copper sulfate will become white, and then you will have your H2O. And then calculating the molar mass. So first thing you need to do, you need to calculate the molar mass of the copper sulfate. Again, I always tell my students, a chemistry student must always have a calculator and a periodic table. So you will go to your periodic table and check the mass of copper, and check the mass of sulfur, and check the mass of oxygen, because there is O in front of, I mean there is 4 in front of oxygen. You need to make sure you multiply mass of oxygen times 4, then you add with sulfur, and then you add with mass of copper, and then you go to hydrogen. You say 5 times 2, I mean 1, I mean 1 times 2, which is 2 plus 5, I mean times 2, and then it will give you, look what happened here, it will give you 10, right? And then you say 5 times 16, then you can see you must do it in brackets, so that you get the molar mass which they are looking for, and then the answer is going to be 249.5 gram per mole. And then after that, this is how you calculate the heart rates. Like I said, I'm going to show you on episode 2 in a nice way, doing different questions. Now we got percentage composition of a compound. How do we to calculate percentage composition of a compound? Okay, percentage of each element present in a compound. Determine the percentage composition of the element in carbon dioxide. The first thing you need to do is to calculate the molar mass of carbon dioxide. Carbon is 12 mass and oxygen is 16, which is times 2. Then you get 44 gram per mole. And now you calculate the percentage of carbon alone and the percentage of oxygen alone. Carbon is 12 mass divided by 44, which is the total of the molar mass of the whole carbon dioxide. Then percentage composition, of course, we need to convert it to 100. Then we multiply by 100. Then you will have 27 of percentage of carbon and 72.73 percentage of oxygen. Simple percentage composition. We can't talk too much about it because it's just straightforward, nothing complicated on it. And let's go to molar gas volume. As you can see, there is another formula that you need to know, which is N equals to V over Vm. One thing you need to know is that at STP, 1 mole of gas occupies a volume of 22.4 diameter cube at STP, right? So Vm means molar gas volume, which is 22.4 diameter cube. Okay, students, I want you to participate, to learn and stay focused. Respect your teacher. I'll come with episode 2, trying to explain through different questions and continue from here. Thank you for watching. Yes, sir.